Sathyabama Institute of Science and Technology.
Hello all, myself Vinothini, Assistant Professor, Department of Computer Science, Sathyabama Institute of Science and Technology. So today we are going to discuss the topic in theory of computation, that is conversion of NFA to DFA. There are many methods in this conversion. So today we are going to see the subset construction method. So here the conversion of NFA to DFA, basically we have to know what is the conversion of NFA and the conversion of DFA. Very basic things, the 5 tuples we have to know. First thing is the states, what is state, and then initial state, final state, and the transition function for all the diagrams. So here is the terminology I have mentioned here for NFA and DFA. For NFA, there are totally 5 tuples, and DFA other 5 tuples. Only difference is the transition function. For DFA is the states, number of states, and for NFA, the transition function is 2 power q. Q is nothing but the number of states that is there in the diagram. So we are going to see the first example in the conversion of NFA to DFA using subset construction method. Here the condition is, the language is, the string they have given is 0 and 1, and the string that ends with 101. So the condition is the string should end with 101. So what are all the strings that ends with 101 should be accepted by the diagram. First step, we are going to see step by step process. Only 6 steps are there. The first step is, using the condition you have to draw the diagram first. The first thing is the transition diagram. So from the question we know the inputs are zeros and ones, and the condition is ends with 101. So firstly for the condition we have to draw the diagram. So obviously the string may contain 101 in it. So for 1, 0, 1, the transition is occur from one state to another. Okay, that's a simple diagram. For 101 you have to draw the diagram first. So totally we need 4 states for this. So from A to B 1 will go, from B to C 0, and C to D 1. Okay. So the question is ends with 101. They didn't mention anything about the beginning thing. So beginning you can have either zeros or ones, so that I have put the self loop. Okay. So the beginning you can get either zeros or ones, but the end should be 101. So this is the diagram I have drawn here. So here the number of states is A, B, C, D, 4 states are there. Initial state is A and final state is D here. So from that diagram you have to draw the transition table. So this transition table contains states and the input zeros and ones. Okay. So how many states we have seen in the diagram is 4 states. So A, B, C, D, 4 states are there, and the inputs are zeros and ones. So I have mentioned the input zeros and ones. So how you have to draw the transition table from the diagram we'll see. Okay. See A state, first state. From A, if you get 0 as an input, you have to check the diagram where it goes. Okay. So from A, if you get 0 as an input, it goes to A. Okay. From A, so I have mentioned A here. Okay. So from A, if you get 0 as an input, it goes to A. From A, if you get 1 as an input, it goes to 2 states. One is A, another one is B. Okay. Likewise, check the diagram and you have to draw the table. Okay. So from A, for 0 it goes to A. From A, if you get 1 as an input, it goes to A and also to B. So check for B. From B, if you get 0 as an input, it goes to C. And again in B, if you get 1 as an input, there goes nothing. Okay. So there is no input 1 from B. There is no transition is there. So you have to put empty. Okay. So from A, if you get 0 as an input, it goes to A. From A, if you get 1 as an input, it goes to A and also B. So I have mentioned AB here. From B, if you check, means from 0 it goes to C, and 1 there is no transition, so empty is there. From C there is no transition for 0 input, and for 1 it goes to D. Okay. And final state is D here. So from D there is no inputs or passing to any states. Okay. So I have given empty and empty. Okay. So this is how you have to draw the transition table from the diagram what you designed already. So here the step 3 is transition function you have to find for this diagram. Okay. So here I already mentioned the NFA, for the NFA the transition function is 2 power q. Q is nothing but the number of states. So the number of states is A, B, C, D, totally 4 states we had. So 2 power q is 2 power 4, 2 power 4 is 16. So, totally 16 set of states we have to, set of strings we have to write it, okay. So, here I have written the subsets are, as usual you have to mention the empty set in the first, and then so what are all the states we had? A, B, C, D, write all 4, and then you have to write the combinations of all the states. So, A, B, A, C, A, D, and then if you go for B, you will get again B, A. So, already A, B combination is there, so I am not going to write the B, A again. So, again B, C, B, D, C, D, and do not write the combination that repeats, okay. So, once the combinations you have written means leave it. So, write all the combinations of A, B, E with the length of 0, 1, 2, 3 and finally 4 length, okay. So, at last you will get A, B, C, D. So, once the subsets are over, what you have to do is totally you had 16 subsets, okay. So, next step is you have to draw the table using all 16 subsets. So, these are all the 16 subsets I have written here. Put state as the first column and you have to write all the subsets 16. So, 1, 2, 3, write in the same order. So, all 16 subsets I have written in the first column, and as usual for 0 input, for 1 input you have to write the remaining columns. So, the first 5 rows is nothing but what the diagram you have drawn already, the transition table from the diagram you drawn, right, the same thing you have to write it here. So, it is nothing but for empty inputs there is nothing. For 0 and 1 you have to put empty, and from A if you get 0 as an input it goes to A, from A if you get 1 as an input it goes to AB, and this table from D is nothing but the table what we have seen before. The same table you are going to draw for first 5, okay, till D you have to draw the same. So, from the previous table the same thing you are going to repeat it here, okay. So, the Q1 is the initial state and D is the final state, you have to mark the same thing and the same table you have to draw it. And the next one is AB, so you have to write all the AB combinations. So, select AB and what the, for the input 0 what is happening in A and what is happening in B. For the input of 0 in A and B you have AC, so put AC here, and for the input of 1 in AB is you have AB, so AB here, and check for AC, A and C, A and nothing, empty. So, you have to put A here, AC for 1 you have AB and D, so you will get ABD here, okay. And for AD the same thing, AD check for A and D. So, A and D, A and empty is here, so put A here, and for AD 1 is AB and empty, so put AB here. In this slide the last one is BC, so check for B and C, B and C, C and empty here, so put C here, and then for 1 empty and D, so put D here. So, you can see the star mark here, this is nothing but you know that already D is the final state. So, where are all the D occurs in the all 16 states, if the D is there means you have to mark it as a final state. So, here AC, AD, BC is here, so AD has D here, so I have mentioned final state, the star mark, and here the remaining thing you have to repeat the same thing for BD, check for B and D. So, BD 0 and BD 1. So, CD of 0 and CD of 1. So, ABC you have to check all ABC all 3, okay, check for all 3 A, B and C. For 0 you have A, C and empty. So, you have to mention AC. So, and then ABC you have to check for 1. You will have A, B, empty and D. So, you have to put A, B, D. So, likewise for all the 16 states you have to fill the inputs for zeros and ones, and then you have to mark the final state for all the states which has D in it, okay. So, finally from that you have to draw the DFA table, okay. So, what you have to do is check the table, take the first one, initial state is Q1 there. So, take the first line and write same as it is, okay. So, Q1, Q1, Q5, this is nothing but if you check with the previous table, I have renamed all the states with the name of Q1, Q2, Q3, Q4 and so on, okay. So, here the initial state I have renamed with Q1 and A here, AB here, okay. So, A I have renamed with Q1 and AB I have renamed AB with Q5 here. So, that is why if you select the initial state, write all the things what are present in the row and you have to rename with the Q1 and Q5. So A, in place of A I am going to write Q1, in place of AB I am going to write Q5. Okay, and the next step, check the rename. So what are all the things you renamed? Check with the table and you have to write the renamed one. Okay, so if you check the table means I have marked this full with Q1, Q2. Okay, so the initial state I have written Q1, Q1 and Q5 here, and here you have to check what is the new state you got here. Okay, so Q1 is already you have the state and Q1 again repeated. The new thing you got is Q5. So what you have to do, you have to go to the previous table and check for Q5 and you have to write the same row, Q5 row here. Okay, if you check for the Q5 means you will get Q6 and Q5. Okay, so here you have to check which is the new state you got. The new state is Q6. So you go to the previous table, check for Q6 and write the same line here. Okay, so you have to write the row what you have in the Q6. So Q6, Q1 and Q13. So here you have to check which is the new state you got. The new state is Q13 I got it. Okay, so you have to write the Q13th row. So Q13, Q6, Q5. And here now you have to check with Q6 and Q5. Is there any new states here? No. Okay, so Q6 is already there here and Q5 is already there. So you have to complete the table here. Okay, so this all 4 rows I have taken from the previous table. Okay, so you have to go and check to the previous table and you have to write all the rows one by one. While you are writing the states, if you got any new state, you have to select that line and you have to write it. Okay, so here you have to mention Q1 is the initial and Q13 is the final. Why Q13 is final? Because Q13 has D in it. Okay, so here Q13 I marked as a final state. So here in this table also I will mark Q13 as a final state. So in this table Q1 is the initial state and Q13 is the final states. So now what are all the things we have done? We have drawn the transition diagram. From the diagram we have drawn the transition table. From the table we have written the transition function. So 2 power q. So from that you got these subsets of 16 subsets of AB combinations. Okay, so you have to write all the things and you have to mark the initial and final state in it, and then you have to check the transition and you have to fill the table. From the table you have taken the initial state and then you have to check for the new state here and you have to write the new state row here. Okay, until it's not repeated. Okay, so till this is clear, I think so. So finally you got the DFA table. So the last step 6 is, from this table you have to draw the diagram. So check the table and draw the diagrams. Totally we have 1, 2, 3, 4, 4 states you have and the inputs of zeros and ones. So 4 state you have with the inputs of zeros and ones. Check the table and draw the diagram. So from Q1, for 0 it goes to Q1, for 1 it goes to Q5, for 1 again from Q5 if you are getting 1 it goes to Q5, for 0 it goes to Q6, from Q6 if you get 1 it goes to Q13, from Q13 if you get 0 it goes to Q6, and from 13 if you get 1 it goes to Q5. Okay, from Q6 it goes to 0. If you are not clear, you have to check, you have to keep both the table and diagram side by side, and if you have to check. Okay, from the table only you have to construct the you have to design the diagram. Okay, so this table I have drawn the diagram here. So there are totally 6 steps. Diagram, you have to draw the diagram, the table, and then the transition function table, and again the DFA table, and then the DFA diagram. So this is how we have to convert the NFA to DFA using the subset construction method. Thank you.